Hi everyone, in this video I want to take a look at some of the regression functions which are available in the Bloomberg terminal. To start off, we'll have a look at the CAPM model. The capital asset pricing model is a regression-based technique and it's learned by near enough every finance student around the world, so that seems a good place to start. Now, in order to run the CAPM model, I need to first pick the company or the security or the equity that I wish to apply it to. Well, I'm going to start by searching for a company. I'm going to search for BAE Systems. They're an arms manufacturer, and given I'm making this video in 2024, they're a company I'm probably going to be interested in, although if my memory is correct, their stock price is actually down today. Well, let's load the security. And, I was right, it is down today, but that's my problem, not yours. Well, if I want to decide, should I add this to my portfolio, to run the CAPM model, I'm going to use the beta function. Just type BETA, hit historical beta. You should now get a screen which looks like this. This is the Bloomberg regression interface, but you also see this for the CAPM function. Now, you can see what the explained and explanatory variables are. Here, I'm trying to explain variation in the share price of BAE Systems using variation in the benchmark index, in this case, the FTSE 100, because it trades in London. I can see the raw beta value here. This is the beta value that the textbooks talk about. Here, it's 0.624. That means around about 62.4% of variation in the index price will reflect into the share price. So is this below market risk? Yes, because beta is less than 1. And actually, I can see the value in the scatter plot here and see that it is actually below the market line. I can go a little bit further back in time if I wish to explore this, or I can shorten the time period, whatever I want to try. I can also fiddle with the periodicity. You'll see it does change the output. Still, my beta's gone up a little bit just with this very random fiddling, but we are still below the market line, about 70% of variation, or on average 70% of variation in index price reflects into the share price, still quite a safe-ish asset. Well, this is just one application of regression in Bloomberg. If I want to work with any other form of data, there is a function called HRA. This is historical regression analysis. This tool looks the same, but I've got the option to choose my dependent and independent variables. Now, there are some few limitations here. I can only have one X variable. I can only run linear models. This doesn't replace eViews or doesn't replace RStudio, but it gives you a very easy way to play with data without having to download it. Well, the function has a habit of remembering the last regression you run. In this case, it's just ran the same CAPM model. But I can pull different data here. And just to prove a point, I'm going to use some macro data. Well, I suppose the most obvious macro data I can think of is UK GDP. And I've got to be very careful in Bloomberg when I'm making choices. Now, I think I'll take the first. So UK GDP market prices quarter on quarter. So that's quarterly data not adjusted for inflation. Hit the enter key. You see I've now changed the variables. So I'm now asking of my model, to what extent does variation in the FTSE 100 index affect UK GDP? And just eyeballing the chart, the relationship looks positive, but there's always a great danger in eyeballing charts. Well, actually, I'm going to go straight to the R square. It's 0.32, so 32% explanatory power, but without knowing about stationarity, I don't know if that's too high or too low. Well, let's look at the t-test. 1.375. Well, for 30 plus observations, working at 5%, the critical value is 1.96. I'm so certain I can remember it. So it's very likely insignificant, and given I have fewer observations, threshold's probably closer to 3. So this is an insignificant model, but I can try something else. Well, Let's just test another theory to show one more limitation of this. There's an idea that certain countries' GDP follows the patterns of other countries' GDP. Well, if I've got UK GDP loaded, let's just pick a neighbouring country. We'll do Ireland, the Republic of Ireland, that is. Now, I've got to be very careful to make sure I'm not comparing apples to potatoes. So I ideally want quarterly data, and I must get it at market prices. Well, market prices and current prices are also the same thing. So I think I can take this one quite safely. Let's run it. Now I probably don't have very many observations here, but let's just go to the max. So we'll go back in time a little bit. So that's given me, 30 years and 4 observations a year. That's probably enough. I can see the beta value is very, very low. The R square value suggests 0.2% explanatory power, so clearly the model's no good. T-test shows mass insignificance. There's no F-test here because it's a single X variable. If I actually wanted to run this model properly and explore the idea of the economic performance of one country spilling over into another country, what I would actually need to do is start to impose a lag structure. I can add lags into the model. Given its quarterly data, if I want to lag 2 years, I enter 8. So managed to get my R square up a little bit, my t-test. Well, my t-value's risen, but I still haven't hit significance. So perhaps I have tweaked that there's a time element to this. Now, I really don't want to start putting random numbers in there and mining my way to the best model. What I would actually be better off doing in this case is going into a proper statistical package and running the correct model. So probably a pairwise angle Granger test or a VAR model. This doesn't replace eViews, it doesn't replace RStudio, but it spares you the agony of having to download data if you just want to quickly explore. And while you're using the Bloomberg terminal, explore the data which is contained within it.